This is the OCR GCSE 9-1 Maths Higher Paper 4 from the November 2020 series, and this paper is a calculator paper. Question number 1 for part A. We have to write these numbers in standard form. First of all, you will recall when a number is written in standard form, it's written as a times 10 to the power of n, where a is in between 1 and 10. Now, if we have the number 6,500, the decimal point is currently here, and we want to move this 1, 2, 3 places to the left, and so what we'd end up with is 6.5 times by 10 to the power of 3. Next, we've got 0.0584. Well, we begin with the 0.0584, and we need to move this decimal place 1, 2 to the right. And so what we'd end up with is 5.84 times 10 to the power of minus 2. Now we have to work out 4.2 times 10 to the power of 5 times 1.8 times 10 to the power of 2, giving an answer in standard form. Well, on our calculator, let's first of all type in this calculation. We've got 4.2 times 10 to the power of 5 multiplied by 1.8 times 10 to the power of minus 2. And if we work out this, we get 7,560. Now, if the decimal point is currently here, we need to move this 1, 2, 3 places to the left, and so what we'd end up with is 7.56 times by 10 to the power of 3. Question number 2. James is taking 3 examination papers in Spanish. Here are his first 2 results. Paper 1, 43 out of 80. Paper 2, 38 out of 65. Paper 3 is out of 95. The marks in each of the 3 papers are added together. We have to find the lowest mark that James needs in paper 3 to achieve 60% of their total marks. The total number of marks we've got 80 for paper 1, we've got 65 for paper 2, we've got 95 for paper 3. Adding these together, we get 240. And therefore, 60% of the total marks, we've got 0.6 multiplied by 240, which turns out to be 144. So he needs 144 marks, and therefore, for him to get 60%, we've got 144, which we need to get 60% overall. We take away the 43 he got in paper 1, we take away the 38 he got in paper 2, and therefore 63 marks are required to get 60% overall. So we have 63. Question number 3. 3 people take 2.5 hours to deliver leaflets to 270 houses. Assuming all people deliver leaflets at the same rate, we have to find how long it will take 5 people to deliver leaflets to 405 houses. We need to give our answer in hours and minutes. Well, if we take a look at information given for 3 people, we know that 270 houses get leaflets, and this takes 2.5 hours. And so what we can do is find out how long it will. We can find out in 1 hour how many houses will get leaflets. 270 divided by 2.5 is 108. So 108 houses get leaflets in 1 hour. This is for 3 people. And therefore, one person in 1 hour, how many leaflets can they deliver? Well, if I divide by 3, one person, we've got 36 houses, which get leaflets in 1 hour by one person. And so for 5 people, in 1 hour, we've got 180 houses which get leaflets. So this is in 1 hour. And so what we need to find out is how long it will take to deliver leaflets to 405 houses for 5 people. So if I work out what this is, to go from the 180 to 405, I need to multiply by 2.25. So therefore it takes 2.25 hours. So we've got 2 hours and 15 minutes, which is equivalent to 2.25 hours. So here I also multiplied by 2.25. Question number 4. In a survey, 60 students were asked whether they have a bank account B and whether they have a part-time job J. The number of students who had neither a bank account nor a part-time job was X, that's shown here, and the Venn diagram shows the results in terms of X. So we've got 2x for B only, 5x minus 2 for J only, and x minus 1 for both B and J. One of these 60 students is chosen at random. We have to find the probability that they have a bank account. So we know altogether we've got 60 people. So we've got x plus 2x plus x minus 1 plus 5x minus 2 equals 60. 3x, 4x, 9x is equal to 63. X is equal to 7. And knowing that x equals 7, here we've got 7, here we've got 14, here we've got 6, here we've got 35 minus 2, which is 33. Now we have to find the probability that they have a bank account. So the probability that we've got a bank account, we've got the 14 plus the 6, so this is the total for a bank, and then we divide by the total, which is 60. So I get 20 over 60, which is 1/3. So we get 1/3. Question number 5. ABCD is a quadrilateral, and that's what we see here. And for part A, we have to construct the bisector of the angle ABC. Show your construction lines. Well, here I've got the angle B over here, and if I put the pointy bit of the compass at the point B, what you can do is intersect the line AB on the line BC, like so. And then pointy bit at this point, draw an arc from there, pointy bit over here, another arc over here, and what we need to do is connect all of those up with a straight line. So here is the bisector as we require. And then for part B, we have to construct the perpendicular bisector of BC. Show all your construction lines. So I need to draw a perpendicular line from BC. So for me to do this, draw an arc here, then over here somewhere, retaining the same radius. Draw the same thing here. Connect these up with a straight line. So the perpendicular bisector then is shown here. And then for part C, we have to shade the region which is nearer to BC than to AB and nearer to B than to C. Well, I want it to be nearer to BC than AB, so I want it above this line, everything above over here, and then I want it to be closer to B than to C, so I want it to the left here as well. So the region I want is the region enclosed by this triangle. So let's shade in all of that. Here is the required region. Question number 6. A cuboid measures 6 cm by 8 cm by 15 cm. A cube has the same volume as the cuboid. We have to find the surface area of the cube, giving an answer correct to 3 significant figures. Here we've got the cuboid. The volume of the cuboid, that's equal to 15 times by 8 times by 6, and if I work this out, we get 720 centimeters squared. So the area of the cube will also be 720 centimeters squared. So therefore, the volume of the cube is 720 centimeters squared. Now, if the side length of a cube is x, then x cubed is equal to 720, and therefore x is equal to the cube root of 720. So if I work this out, I get 8.96, etc. So therefore the surface area of the cube, that's going to equal 6 because I've got 6 faces, lots of 8.96, etc. squared. This is one face. So if I square this and times by 6, it turns out that the surface area is equal to 481.99, etc., which to three significant figures, we have 482. Question number 7. This graph shows part of a straight line. For part A, we have to show that the gradient of the line is 2.5. Now, for the gradient, we need the change in y over the change in x. So, the change in y, let's pick any 2 points. For example, this one and this one. The change in y, we are going from 4 to 9, so that change in y is equal to 5. The change in x, we are going from 2 to 4. The change in x is equal to 2. And therefore, the gradient is equal to the change in y, which is 5. So we've got a change in y over the change in x for the gradient. So I've got the change in y, 5, the change in x, 2. So it turns out the gradient is therefore equal to 2.5. And then it says, write down the equation of the line. We need the y-intercept. The y-intercept is here. At -1. So our equation of the line is of the form y equals mx plus c, where m is the gradient and c is the y-intercept. The gradient m is 2.5, so we've got y equals 2.5x plus c, and c is -1. Question number 8. Lily buys and sells microwaves. She buys each one for £32 and sells it for £60. She also pays £7 for the delivery of each microwave she sells. If she sells a microwave that is faulty, then Lily must pay for its repair and redelivery. This costs her another £25 for each faulty microwave. Last month, 6 out of the 80 microwaves Lily sold were faulty. This month, she has orders for 133 microwaves. We have to calculate her expected percentage profit on this month's order. Showing your working in the boxes below may help you present your work. Well, what we can do is find out how many microwaves we expect to be faulty. Now, we know already last month 6 out of 80 were faulty, and this month we've got an order of 133 microwaves, so we can expect 60 over 80 times 133, and if we calculate what this is, we've got 6 divided by 80 multiplied by 133, and it turns out here we get 9.975, and therefore we can conclude we've got 10 faulty microwaves this month. We round this number up, and what we can now do is find out the expected costs. So she's ordering 133 microwaves, and the cost of this, well, we know already she buys each one for £32 and she sells the microwaves for 7. So the expected costs are shown here, and then we need to add on in terms of the faulty microwaves. Well, we've got 10 of them and 10 of them to repair and then sell. That's 25. So we can find out the expected costs. So if we calculate this, we get 5,437. This is the expected costs. We can also find out the income. Now, if she's got 133 microwaves, which she ordered, and we know already that she's selling them for £60, then the income from sales is 133 multiplied by 60, which is £7,980. So the expected percentage profit, we've got 7,980 minus 5,437 divided by 5,437 multiplied by 100. So if I work this out, 7,980 minus 5,437 over 5,437 multiplied by 100, we've got 46.77, etc. So we've got 46.77 to 2 decimal places as our expected percentage profit. Question number 9. The graph shows the number of umbrellas sold in Ling's shop for each quarter from quarter 1 of 2017 to quarter 3 of 2019. And for part A, the shop sold 32 umbrellas in quarter 4 of 2019. We have to complete the graph. So we've got 32. So if I draw a line up from quarter 4 to 32, well, 35 is over here, so 32 will be around here somewhere. So here is 32 plotted. We've got 32 umbrellas in quarter 4. And for part B, we have to make one comment about the seasonal variation shown in this graph. Well, if we take a look at the seasonal variation, you can see it peaks in quarter 1, and that's what we see here. Quarter 1 in each season is always highest. And for part C, we have to make one comment about the annual variation shown in this graph. Well, if we take a look at what's happening during the year, then we can see overall there is a rise in the sales almost. So there is a slight rise in sales year on year. And now for part D, Ling predicts that she will sell 50 umbrellas in quarter 1 of 2020. What assumption has she made? Well, if that's the case, she's assuming the trend in her sales will continue at a similar rate. Question number 10. The diagram shows Jane's lawn. It's in the shape of a square of side 36 meters and 3 semicircles. She's going to spread fertilizer on the lawn at a rate of 30 grams per square meter. The fertilizer is only sold in 10 kilogram bags, costing £15.80 each. You have to calculate the cost of buying the bags of fertilizer for her lawn. You must show all your working. Well, we've got the side of the square being 36. And what we can also do is find out the radius. The radius will be half of the 36. This is the diameter, so half the diameter is the radius. Here we have 18. And you will also find that here we've got kilograms and here we've got grams. So at some point, we also need to convert the units. Grams to kilograms, we divide by 1000. Kilograms to grams, we multiply by 1000. What we can do is find out the area of the lawn. The area is equal to, well, I've got 36 times 36, and then I need to add on to this 3 semicircles. Those have areas. Pi times 18 squared divided by 2. Area of a circle divided by 2 is the area of a semicircle. So let's work all of this out. 36 times 36 plus 3 lots of pi times 18 squared over 2. We get 2,822.8 etc. meters squared. So we can find out how much fertilizer we require. We know that we are spraying fertilizer on the lawn at a rate of 30 grams per square meter. Now we've got this many square meters, so the amount of fertilizer we require, we've got 30 grams per meter squared multiplied by 2822.8 etc. meters squared. So if I multiply this by 30, I get 84,684 grams. So I have 84,684.42 etc. grams. And if I divide this by 1000, then I end up with 84.68 etc. kilograms. So the number of bags we need, well, we know that fertilizer is sold in 10 kilogram bags. So the number of bags we require, we've got 84.68 divided by 10, which is 8.4 etc. So we require 9 bags. And if one bag costs £15.80, the total cost will be 9 multiplied by 1580, which is 142.20. So we've got £142.20. Question number 11. For part A, the length D of Jamal's car is 4.72 meters, corrected 2 decimal places. We have to complete the error interval for the length D. Well, we've got 4.715 being less than or equal to D being less than 4.725. A value of D which satisfies this inequality will round to 4.72. Now for part B, Jamal travels for 30 kilometers, correct to the nearest 10 kilometers. His average speed is 57.3 kilometers per hour, correct to 1 decimal place. We have to calculate the shortest possible time for Jamal's journey. Give your answer correct to the nearest minute. Well, we know that time is equal to distance divided by speed. Now what we want is the lower bound of the time, because we are looking at the shortest possible time. Now, how could I get a fraction which is as small as possible? Well, I need the lower bound of the distance divided by the upper bound of the speed. So I've got the lower bound of the distance, 425 kilometers, divided by the upper bound of the speed, 57.35 kilometers per hour. So if I work out what the time is, we have 425 divided by 57.35. We have 7.416 hours. So that's equal to 7 hours, and this 0.4 etc. hours, if I times that by 60, I get 7 hours 24 minutes. Well, it did say to the nearest minute, so let's round that up. So we've got 7 hours 25 minutes. Question number 12. Triangle T is drawn on the coordinate grid, that's what we see here, and we have to translate T by the vector -6, 2. Now if I pick any point, for example this one, I need to go 1, 2, 3, 4, 5, 6 to the left, and then I go 2 up. So that corresponding point will be over here. And then I finish off the triangle. The triangle would look something like this. And then it says, describe fully the single transformation that is equivalent to a reflection in the line y equals x, followed by a reflection in the x-axis. Well, let's do this first bit. Let's reflect the triangle in the line y equals x. Well, the line y equals x is what we see here, so we need to reflect this triangle in the line y equals x. Well, here is a reflection in the line y equals x, and then I reflect the graph in the x-axis. So if I reflect in the x-axis, here is the x-axis, what we'd end up with is the shape over here. So what we are questioning is, how do I go from this to this over here? Well, what this is the same as is a rotation 90 degrees clockwise about the origin. As we see here, this is moving 90 degrees to this point, and this is moving 90 degrees to this, and then so on and so forth. Question number 13. Ali and Beth take it in turns to play a computer game. On each turn, the player achieves a score out of 50. Ali and Beth play the computer game many times and record their scores. Ali's scores are summarized below, and what we have to do is draw a box plot to show the distribution of Ali's scores. So we've got the median at 31, so that is over here. We've got the highest score at 38, so the highest score is over here. The lower quartile is 24, and the interquartile range is 11. So what else can we work out from this? Well, lower quartile is 24. 24 is over here. we can work out the upper quartile from the information provided here. The upper quartile is equal to the lower quartile plus the interquartile range. So the interquartile range is the upper quartile is 24 plus the 11, which is 35. So we've got 35 for the upper quartile. So we've got lower quartile, median, upper quartile. That is all shown here. We've got the highest score and then we've got the range. So the lowest score well, we've got the highest score 38, take away the range 23, and if we work this out we get 15. So the lowest score is 15, which is over here. So here is the box plot. And then for the next part of the question, this box plot shows the distribution of Beth's scores, and we have to find the interquartile range. The interquartile range would go from here to here. So we have the interquartile range equaling the upper quartile, which is 37, take away the lower quartile, 21. So the interquartile range is equal to 16. For part C, Kareem says Beth was more consistent than Ali because Beth had a lower median score. Is his statement correct? Well, here his statement will be incorrect because for consistency we need to compare the interquartile range. So let's write down a full explanation. So consistency is measured by the interquartile range, and you can see Ali had a lower interquartile range and therefore he had a more consistent score. Question number 14. The diagram shows triangle ABC. AC is 15, BC is 18 and the angle BAC is 72 degrees. We have to calculate the length of AB, giving our answer to 3 significant figures. Well, first thing we can do is find out the size of the angle B over here, and we can do this using the sine rule. So the sine of B over the length opposite it, 15, is equal to the sine of 72 divided by the length opposite it, 18, and from this we can find out what sine B is. So sine of B is equal to, well, here we've got 15 sine 72 over 18, and working this out as a decimal, we get 0.79, etc. And therefore, the angle B is equal to the inverse sine of this, which is 52.42, etc. So we have 52.42, etc. degrees. We can now find out what this angle here is, and we can do that by recognizing that some of the angles in a triangle add up to 180. So the angle C is equal to 180, take away the 72, take away the 52.42, So if I find out what the angle C is, 180 take 72, take away this, is 55.57. So I have 55.57, etc. degrees. What I can also do is work out the size of AB now using the cosine rule. AB squared is equal to 15 squared plus 18 squared minus 2 times 15 times 18 times by the cosine of 55.57, etc. So if I work out what AB squared is, I've got 15 squared plus 18 squared minus 2 times 15 times 18 times the cosine of the angle, which is 243.72, etc. And so the length of AB is the square root of this, which is 15.611, etc. centimeters. So I have 15.6 centimeters given to one decimal place. Question number 15. Here are two pieces of work, and for each one we have to describe the error and give the complete correct solution. So here we have to solve 3x squared minus 2x minus 5 equals 0 by factorization. Someone got 3x plus 5 lots of x minus 1 equals 0, and so therefore x equals minus 5 over 3 and x equals 1. Well, if I take a look at the error over here, what we can do is, well, we'll work out our own solution and then see where they've gone wrong. I've got 3x squared minus 2x minus 5 equals 0. First thing we'll do is we'll find out two numbers which multiply to give 3 times minus 5, which is minus 15, and which add to give minus 2. What are those two numbers? Well, we've got minus 5 and 3. So I've got 3x squared minus 5x plus 3x, rather, let's do this the other way around. I've got 3x squared plus 3x minus 5x minus 5 equals 0. So I've got 3x lots of x plus 1 minus 5 lots of x plus 1 equals 0. So I've got 3x minus 5 lots of x plus 1 equals 0, from which I can see either the 3x minus 5 equals 0, or I've got x plus 1 equals 0, and therefore x is either equal to 5 over 3 or x is equal to negative 1. So the error made over here is the factors are 3x minus 5 and x plus 1, which is what we got here. Next, for part B, we have to solve the quadratic equation 2x squared minus 8x plus 3 equals 0 to three significant figures. Well, someone did this and I can straight away spot that this is incorrect. Let's work out the correct solution. First of all, if we have a quadratic equation ax squared plus bx plus c equals 0, where a doesn't equal 0, then the solutions to this quadratic are given by x equals minus b plus minus the square root of b squared minus 4ac over 2a. Now, if I take a look at my equation, I've got 2x squared minus 8x plus 3 equals 0. So, I've got a equals 2, b equals negative 8, and c is equal to 3. So I can substitute these in to here. I've got x equals negative b, so here I've got negative 8 plus minus b squared. So I have minus 8 squared minus 4 a c square rooted divided by 2a. So I can find out what x is, and if I find out what x is, I've got negative 8 plus the square root of negative 8 squared minus 4 a c over 2 a. So I get one solution, 3.58, and another solution, 0.419. These are given to 3 significant figures. So what was wrong with their error? Well, the negative b term should be in the numerator. Question number 16. Y is inversely proportional to the square of x. Y is 2 when x is 5. We have to find a formula linking x and y. So, if y is inversely proportional to the square of x, that means y is equal to some constant k over x squared. And we know that when x is equal to 5, y is equal to 2. Substituting these into here, we've got 2 equals k divided by 5 squared. K equals 2 multiplied by 5 squared, which is 50. And knowing that k equals 50, we can therefore conclude y equals 50 over x squared. So we've got y equals 50 over x squared as our formula. Question number 17. We have to expand and simplify x plus 1 lots of x minus 1 lots of x plus 2. First of all, you may spot we've got a difference of 2 squares here. X plus 1 lots of x minus 1 is the same as x squared minus 1. So we've got x squared minus 1 being multiplied by x plus 2. X squared times x is x cubed. X squared times by 2 is 2x squared. Minus 1 times x is minus x. Minus 1 times 2 is minus 2. So here is our result expanded and simplified. Question number 18. Here is a sketch of the circle x squared plus y squared equals 45. And we have to show that the tangent to this circle at the point minus 3, 6 has a gradient of 1/2. So minus 3, 6 is somewhere over here. And what we want to do is find the gradient of the tangent. So here is the tangent, and we want to find the gradient of this tangent at this point. So here we've got the radius, and we know that the radius and the tangent are perpendicular to each other. We've got the point minus 3, 6 here. So what we can do is find out the gradient of the radius. And recognizing that the tangent and the radius are perpendicular to each other, we can find the gradient of the tangent. So therefore, the gradient of the radius, we've got here the change in y, which is 6, over the change in x, which is -3. So here we get the gradient of the radius is -2, and therefore the gradient of the tangent is equal to -1 divided by -2, which is 1/2. And then for part B, we have to find the equation of the tangent at that point. Well, if I use the fact that y is equal to mx plus c, m is the gradient, c is the y-intercept, I've got this point here -3, 6, so I've got 6, the y-coordinate, equals m, which is 1/2, lots of x, which is -3, plus c. 6 equals -3 over 2 plus c. C is equal to 7 is equal to 7.5, which is 15 over 2. And therefore, knowing what c is and knowing what m is, we've got the equation of the tangent being y equals 1/2 x plus 15 over 2. Question number 19 for part A. The graph shows the speed of a vehicle during the first 40 seconds of motion. That's what we see here. And we have to calculate the distance travelled by the vehicle during the first 40 seconds. Well, the distance we can find by working out the area under the curve. So, if we work out the area under the curve, we've got a trapezium. So the area, which is equal to the distance, we've got 1/2, lots of the sum of the two parallel sides. Now here, I'm going from 15 to 40, so that's 35 this way, plus 40 times by the height, which is 30. So if I work this out, 1/2 multiplied by 35 plus 40 times by 30 rather, here we get 25. So let's just adopt this. It turns out the distance is 975 meters. So we have 975. Now for part B, the graph shows the distance travelled by the particle over 6 seconds. And for the first part, we have to work out the average speed of the particle between 2 and 4 seconds. Well, what we can do here, for us to estimate that time, we can find out the change in y and the change in x between 2 and 4 seconds. So the change in y and the change in x, we've got a change of x from 2 to 4, that's 2. The change in y, we are going from 6 to 24, so that's equal to 18. And therefore, the average speed is equal to 18 meters divided by 2 seconds, which is 9 meters per second. Then we have to estimate the speed of the particle at 4 seconds. We need to draw a tangent at x equals 4. Here is a tangent at x equals 4. The change in x from 2 to 6, that's 4. So here is the change in x, which is 4. And then the change in y, we are going from 0 to 48. So the change in y over here is 48. And therefore the speed is approximately, and the reason it's approximate is because we're estimating. So we've got the change in y, 48 meters, divided by 4 seconds. So we have here 12 meters per second. So we end up with a value of 12 meters per second. Question number 20, we have to solve the equation x squared plus y squared equals 34 simultaneously with y equals x plus 2. If I call this equation 1 and if I call this equation 2, we can substitute in equation 2 into equation 1. And if we do this, we have x squared plus y squared. Now I know what y is. That's x plus 2. And then squared. This is equal to 34. So I've got x squared plus 4x plus 4 equals 34. I've got 2x squared plus 4x. Now here 4 take away 34 is minus 30. And this is equal to 0. If I now divide by 2, I get x squared plus 2x minus 15 equals 0, from which you can see I can factorize this as x plus 3, rather x plus 5, lots of x minus 3 equals 0. So either x plus 5 equals 0 or x minus 3 equals 0, from which we can conclude x is either equal to minus 5 or x is equal to 3. So knowing what x is, we can now find out what the corresponding values of y are. So if I've got x equals 5 or minus 3, the corresponding y values, I've got y equals minus 5 plus 3, which is, rather, minus 5 plus 2, rather, which is minus 3, or we've got y equals 3 plus 2, which is equal to 5. So I've got solutions. X equals minus 5, and the corresponding y value is minus 3, or I've got x equals 3, y equals 5. So here are my solutions to the system of equations shown here.